Good morning, children. So we'll continue with the order and degree of the differential equation. These problems are very important for 2 marks. Definition is important, and then problems are also very important for 2 marks. And you should understand these two terms, order and degree of a differential equation, because when you go to higher classes, you need this definition. Once you observe what is the order and degree, you can think of that particular method and solve the equations. So we need all this. So this is one example. Dy by dx is equal to this. So what is the order? If you observe here, the derivative power is an integer only. These things can be any fractional powers or any irrational numbers like that. As far as derivative is concerned, the power of the derivative is an integer. So you can say that the order is 1 and degree is also equal to 1. I'll write with so here the order is 1 and degree is also 1, because you have the highest order derivative as dy by dx like that. Here if you see, you have the power as 5 by 3. For derivative also you have the power as a fraction. So what will you do in the second problem? You will cube on both sides. So d square y by, I'll write as y2 y1 like that. Then it will be easy for us to simplify the equation. So I'll write d square y by dx square as y2 is equal to 1 plus y1 square whole to the power 5 by 3. So now we cube on both sides. So you'll get y2 cube is equal to 1 plus y1 square whole to the power 5. So whatever it is, the highest order derivative is y2 derivative d square y by dx square. So the order is 2 and its power higher. You don't have any more y2s here. So the highest power of y2 is 3. So its degree is 3. So for second problem, the order is 2. The order is 2 and the degree is 3, because the highest power is 3 like that. Now in the same way here, you have 2 here. So squaring on both sides, what happens in the third problem? It is 1 plus y2 square. This is already y2 square is equal to 2 plus y1 square. dy by dx means y1 square whole to the power 3 by 2 here. So you should not have fractional power. So you will square on both sides. So it becomes 1 plus y2 square whole square is equal to 2 plus y1 square whole cube. y1 square whole cube. So what is the highest order derivative? y2. So the order is 2. And what is the highest power of it? When you expand this, you will get 1 plus y2 whole to the power 4 plus 2y2 square. 2y2 square is equal to, so on you will get. So you have to write actually. So this is a plus b whole cube formula. You write all the terms here. So what is the highest order derivative? y2. And what is the highest power in this? The power for y2 here is 2 and the power for y2 here is 4. The greatest among these two is 4. So the order is 2 and degree is 4. So for this problem, the order is 2 and the degree is equal to 4. Okay. Now if you see this problem, fourth problem, you have all fractional powers only, but on the right side you have 0. On the right side you have 0. So it is very easy to get it in the standard form. So what can you do here? You can just, it is like dy by dx whole to the power half. So dy by dx whole to the power half means y1 power half plus y2 to the power 1 by 3 whole to the power 1 by 4 is equal to 0. This is the fourth problem. So that means when you take power as 4, then it is just y1 whole to the power half plus y2 whole to the power 1 by 3 is equal to 0. So again you take one term to that side. y1 power half is equal to minus y2 to the power 1 by 3. Now here the power is 2, here the power is 3. The LCM for 2 and half and 1 by 3. The LCM for both of them is 6. So you take the powers on both sides to 6. Whole to the power 6 you take is equal to minus y2 to the power 1 by 3 whole to the power 6. Then what happens? This becomes y1 means dy by dx. So dy by dx whole to the power 6 by 2, that means 3, is equal to minus 1 power 6 is plus 1 only. So it is y2. y2 means d square y by dx square whole to the power 6 by 3, that is 2. Okay, now this is your equation which is free from radicals. Fractional powers are removed. So now what is the order? Highest order derivative is 2 here. D square y by dx square. And what is its power? Its power is 2. So its order is 2. Degree is also 2. So for this problem, the order is 2. The order is 2 and degree is also 2. Degree is also equal to 2. So like this you have to do. Now in this fifth problem is again very important. So in the fifth problem, you have d square y by dx square. So in the fifth problem, you have y2 plus 2y1 plus y is equal to log of y1. So here you should not have any fractional powers. It should be a polynomial equation in the derivatives. Do you have it as a polynomial equation in derivatives? Can you make it a polynomial equation? You have logarithm. So you cannot make it as a polynomial equation in the derivatives. So order wise you can write order as 2. Order is 2 because you have d square y by dx square. But degree you cannot find out because to remove this, what will be the power, that we cannot find out. So here degree is not defined. We say that degree is not defined for this equation. Okay, here it is direct. Order is 2 and degree is 1. Here order is 2 and degree is 1. Here also order is 3. Order is 3 and degree is 2. Degree is 2. Now we'll learn about the solution of a differential equation. How to form a differential equation and how to write the solution of a differential equation. So these examples are very important. Okay, two more examples I didn't discuss. So we'll do those two also. This erased. Here are two examples I wrote. Okay, they are okay, these two problems. X to the power half. The eighth problem was x to the power half into d square y by dx square whole to the power 1 by 3 plus x into dy by dx plus y is equal to 0. So here again you have fractional power for derivative. So you must write x power half into d square y by dx square whole to the power 1 by 3 is equal to minus x dy by dx plus minus y. Now this should be removed. This you can have as a fraction, no problem, but this power should be removed. So what will you do? You will cube on both sides. So cubing on both sides. Cubing on both sides, you get x to the power half whole cube into d square y by dx square whole to the power 1 by 3 whole cube is equal to minus x dy by dx minus y whole cube. Okay, so now the highest order derivative is this d square y by dx square. What is the highest power for it? 1. So the order is 2. The order is 2 and degree is 1. So this here you can have any fractional coefficients. But as far as derivatives are concerned, you should have integers. It should be a polynomial. Here also when you expand, it will be a polynomial equation in derivatives only. So the order is 2 and degree is 1. Now the next example is very important. It is very important. D square y by dx square, and it is tricky. The question is tricky. Y by dx whole cube whole to the power 6 by 5. Whole to the power 6 by 5 is equal to 6y. So you may think, like in all the earlier problems, we just thought of the denominator and took that power on both sides, whether it is cubing or squaring, like that. But here you have 6 by 5. So don't think of taking the power of 5 on both sides, because here on the right side you don't have any derivatives. So you can take this 6 by 4 directly to the right side. That means you can write d square y by dx square plus dy by dx whole cube is equal to 6y whole to the power 5 by 6. So these coefficients, as far as x and y are concerned, you can have fractional powers, but derivative should not have any fractional powers. So here we removed this exponent, fractional power, by just taking it to that side. That means you are taking the power 5 by 6 on both sides. So now this is your equation in the standard form, and hence its order is, so for this problem the order is 2 and degree is 1. Degree is 1. So don't think of taking only power 5 to that side. So you can take the whole power to that side, so that the equation becomes free from fractional powers as far as derivatives are concerned. And so the order is 2 and degree is its power, that is 1. So this is very important. And okay, now we'll learn about the forming a differential equation when solution is given, and then solving the equation when the differential equation is given. So there are two things here. First one is, suppose that we will take one example. Suppose that you are given x value, x is equal to 2 and 3. Find an equation whose roots are 2 and 3. Then what will you do? You will write the equation as x minus 2 into x minus 3 is equal to 0. So when roots are given, you can find the equation like this. So that is x square minus 5x plus 6 is equal to 0. So the equation whose roots are 2 and 3 is this. So 2 and 3 are the solutions of this equation. So like this you say. In the same way, this is just an algebraic equation and it is easy to solve. Whereas in differential equations, you have like this. Suppose that you have some a cos x plus, okay, only a cos x I'll take. Now, it has only one, this is called as arbitrary constant. A is called as an arbitrary constant or parameter. So, suppose that you have y is equal to a cos x. It has only one parameter. So, this is the solution of some differential equation. You must form a differential equation. Like when you are given the solution, you are able to write the equation. In the same way, when solution is given, how to form the differential equation. So there is a particular rule or procedure. It is like this. In the solution, you must see how many constants, arbitrary constants or parameters are there. Here you have only one parameter. So you must differentiate this equation only once, one time. So differentiating with respect to x, dy by dx is equal to derivative of cos x. Cos x is minus sin x. Derivative of cos x is minus sin x. So like this we'll do. Now what you do from these two equations, you must eliminate a, the arbitrary constant. So whatever equation you get, that becomes the differential equation for which this is the solution. So for eliminating, there is no particular method. You yourself should think. Sometimes by subtracting it may get eliminated. Sometimes by substituting one in the other, like that. So there are many ideas. Each problem has different idea to eliminate the arbitrary constants. Here you may think like this. I'll find out a from this. What is a? A is equal to y by cos x. So now I'll substitute this a here. So I'll get dy by dx is equal to, what is a? Y by cos x. So y by cos x into minus sin x. That's all. So a got eliminated now. So this is the equation. So what is the equation? Dy by dx. So dy by dx is equal to minus y tan x, or dy by dx plus y tan x is equal to 0 is the differential equation for which a cos x is the solution. So like this we form the differential equation. Now suppose that so here what did we do? We found a and substituted. Or sometimes you may think, divide one equation by the other, divide one by the other. Then whatever, then also you'll get the same equation. Equation is unique. You will get the same equation. Whatever may be the method, you get the same equation. But the simplification may be different. I'll write dy by dx as y1 is equal to a cos x by minus a sin x. So what happens? This a gets cancelled. It is the same thing here. So like this, you have different ideas to form the differential equation, to eliminate the arbitrary constants in those equations. Now suppose I have y is equal to a cos x. Suppose I have, instead of a cos x plus b sin x, a cos x plus b sin x. Now this is the solution. Form a differential equation for which this is the solution. Then what you do, first you will observe how many arbitrary constants are there in this equation. There are two arbitrary constants, a and b. So you have to differentiate 2 times. So differentiating twice successively. So all those steps we should write. This is just an example. So dy by dx is equal to a into derivative of cos x minus sin x plus b into derivative of sin x is cos x. Again, if you differentiate, it is d square y by dx square is equal to a into what is the derivative of minus sin x minus cos x plus b into derivative of cos x. Derivative of cos x is minus sin x. So you can take minus 1 common, minus of a cos x plus b sin x. So here, without using these equations, you can directly eliminate like this. A cos x plus b sin x is nothing but y. So you can just write minus y. That's all. So that means what, d square y by dx square is equal to minus y, or d square y by dx square plus y is equal to 0 is the required differential equation for which this is the solution. So here we didn't find any solve for any a or b. Directly we could get the equation because in the second order derivative we could able to write it as minus y. So like this we form the differential equation when solutions are given. There is one more observation here, that is, in the solution you must see how many arbitrary constants are there. So if there are 2 arbitrary constants, you will differentiate 2 times only. You should not go for the third order derivative. So how many arbitrary constants or parameters are there? So many times only you have to differentiate successively. So the order of the differential equation you can directly write, even without finding all this. You can write the order as 2 because there are 2 arbitrary constants. So like that you can write the order of the differential equation for which the solution is given. Now just now we discussed about this solution. So the general form of an ordinary differential equation of nth order, it will contain, the general equation will contain x terms, y terms, dy by dx, d square y by dx square, b in nth order derivative, like this. So this is the general definition. Now order of a differential equation is equal to the number of arbitrary constants in the solution. Just now we discussed. Number of equations required to form the differential equation. So you are given y is equal to some a cos x. So you are finding y1. y1 is equal to minus a sin x. So you have only one arbitrary constant and you need 2 equations to eliminate. So if you have 2 arbitrary constants, you need 3 equations to eliminate the arbitrary constants. So you need 1 equation extra to eliminate the arbitrary constants. So the number of equations required to form the differential equation is number of arbitrary constants plus 1 extra equation. Generally the solution means it will contain x, y, like that, along with some arbitrary constant. You have seen y is equal to a cos x plus b sin x is the general solution. So it is a solution of some differential equation. Now if it has 2 arbitrary constants, so the solution of a differential equation in which the number of arbitrary constants is equal to the order of the differential equation is called as general solution. General solution is also called as primitive of the differential equation. So you have seen d square y by dx square is equal to minus y we got. So for this equation, this is the solution. So it has two arbitrary constants. So we say that it is a general solution. Actually, for d square y by dx square is equal to minus y, you can see cos x, y is equal to cos x is a solution and y is equal to sin x is also a solution. Actually, these are two different solutions for this. By combining these two solutions with an arbitrary constants like this becomes the most general solution. You can see, suppose I take y as cos x, y is equal to cos x. Then what is y1? y1 is equal to minus sin x. Then what is y2? y2 is equal to minus cos x. Y minus cos x means minus y. So y2 is equal to minus y, satisfies. So y is equal to cos x and y is equal to sin x are two separate solutions of this equation. When you are combining them with arbitrary constants, that becomes the general solution of the differential equation. Now for this general solution, if I give particular values, any values I can give, minus 2 plus 9, any numbers you can give, that becomes a particular solution or particular integral. We use that word also. But in this chapter, we won't be using this particular integral. We use particular solution. So particular solution is the solution where you give particular values to the arbitrary constants. You give particular values, special some numbers, integral values, integral or any real values to the arbitrary constants. That becomes the particular solution of that differential equation. Now we'll do the problems. We'll solve some problems and you can try some problems. You can take them as homework. Okay. Now first problem. Form a differential equation. Form a differential equation corresponding to y is equal to cx minus 2c square, where c is a parameter. So that means only c is the arbitrary constant here. So you must find the differential. Form a differential equation for which this is the solution. So what will you do? You will write. I'll write with this one. So in the solution, you are given y is equal to cx minus 2c square. There is only one arbitrary constant. So I'll write the steps. Differentiating with respect to x. So that means d by dx of y is equal to d by dx of cx minus d by dx of 2c square. This is equation 1. 2c square. C is a constant. So this whole thing is a constant. Derivative of constant is 0. So this is 0. And what is the derivative? C is a constant. Derivative of x is 1. Derivative of x is 1. So dy by dx is equal to c. So that means you got dy by dx as equal to c. Now eliminating c from 1 and 2. So eliminating, how will you eliminate here? Eliminating c from 1 and 2. So how are you eliminating? You got the c value. So directly substitute. That's all. So y is equal to c. C means dy by dx. Cx minus 2 into c square. That means dy by dx whole square. So eliminating c from 1 and 2, we get this equation, which is the required differential equation. So like this we do, which is the required differential equation. Okay. The next problem. So when you are writing the final equation, you write dy by dx only. In between, if you want, you can write y1 and all. But finally, you write dy by dx only. Okay. Now next problem. Form a differential equation corresponding to y is equal to a cos 3x plus b sin 3x. Just now we have seen where a and b are parameters. where A and B are parameters. So now what will you do? You take the solution. Y is equal to A cos 3x plus B sin 3x. So here it is 3x. So in the solution you write, you are given y is equal to A cos 3x, A cos 3x plus B is sin 3x. Now, because we have two arbitrary constants, you must differentiate it twice. So we'll write differentiating it twice successively with respect to x. With respect to x, we get what is the derivative dy by dx is equal to a into d by dx of cos 3x plus b into d by dx of sin 3x, d by dx of sin 3x. So now what is the derivative of cos 3x? And do it here. d by dx of cos 3x, d by dx of cos 3x. Outer function is cos. Derivative of cos is minus sin. So minus sin 3x into the derivative of inner function. Inner function is 3x. So minus sin 3x into derivative of 3x, that is 3. So it is minus 3 sin 3x. So in the same way you write the derivative of sin 3x also. So that means this implies dy by dx is equal to a into this derivative is minus 3 cos 3x. Minus 3 cos 3x plus b into 3 sin 3x. 3 sin 3x. So this is equation 1 and this is equation 2. Equation 2. Now again differentiating successively we wrote now. Okay, we'll write again differentiating. D by dx of dy by dx is equal to a into minus 3a, we'll write outside, minus 3a into d by dx of cos 3x plus 3b into d by dx of sin 3x. d by dx of sin 3x. Yeah? So it is equal. So now what is this? This is d square y by dx square is equal to minus 3a into derivative of cos 3x. We found now. So minus 3 sin 3x plus 3b into, again derivative of sin 3x is 3 cos 3x. 3 cos 3x. Okay, now we can make it 9. So 9a sin 3x, 9a sin 3x plus 9b cos 3x. 9b cos 3x. You can take 9 common, then it becomes a sin 3x plus b cos 3x. b cos 3x. So you can actually from these three equations you must eliminate the a and b. But we can observe that without using the second equation itself, here we got a sin 3x plus b cos 3x as y. So I can just write is equal to 9y. So this implies d square y by dx square plus 9 is equal to 9y is the required differential equation. Is the required differential equation. So like this we found the differential equation when solution is given. Now you can try some problems. So you can just take down this. Okay, now I'll just write the homework problems. Question is same. Form a differential equation corresponding to the following equations. Form a differential equation of the following family of curves. Family of curves means parameters. For different values of parameters you'll get different equations. So that becomes a family. So y is equal to a e to the power 3x plus b e to the power 4x. So for different values of a and b, you will get different equations. All those equations curves becomes one set of curves or family of curves. So here a, b are parameters. Okay, now second bit, y is equal to ax square plus bx. Here also a and b are parameters. Third one, ax square plus by square is equal to 1. A and b are parameters. So you will differentiate 2 times. You can easily get the, you can eliminate. Next to fourth one, xy is equal to ax square plus b by x. So here a, b are parameters. So the answers are, for first one it is d square y by dx square minus 7 dy by dx plus 12y is equal to 0. Okay, now second one, x square into d square y by dx square minus 2x into dy by dx plus 2y is equal to 0. We just try this problem. These are very easy, but first one, I think I'll try to do it in the next period. xy into d square y by dx square plus x into dy by dx whole square minus y into dy by dx is equal to 0. And then the answer for fourth one is x square d square y by dx square plus 2x dy by dx minus 2y is equal to 0. These are the answers. You can just try.